Welcome to The Explainer. Today, we're pulling back the curtain on artificial intelligence. We're going to ask, what does it actually take to build a machine that can think for itself? Let's meet the people behind the code and really dig into their mission.
So yeah, this is it. This is the question driving one of the most fascinating fields in technology right now. And look, we're not just talking about slightly smarter chatbots or getting better search results. We're talking about creating genuine, independent autonomy. So how in the world do you even begin to do that? Let's find out. Okay, so it all starts with the mission. What's the North Star here? The ultimate goal isn't just to process information more efficiently. It's to create systems, or what researchers call agents, that can operate all on their own out in the real world to get things done.
So an agentic AI is not some passive tool just sitting there waiting for your next command. No way. It's an active participant. It has to be able to perceive the world around it, decide what to do next based on that information, and then, this is the critical part, actually do it. And that's a profound shift in what we expect from our technology.
Exactly. Think of it like this. A search engine gives you a recipe when you ask for one. Great. An agentic AI, on the other hand, goes into the kitchen, sees you don't have any eggs, orders them for you, and then starts prepping the meal. It's the huge difference between a library and a personal assistant. The real goal here is action.
When you boil it all down, this mission really breaks apart into three core challenges. First, you've got to constantly push the frontier of autonomy, always expanding what an AI can do by itself. Second, it's about mastering complex planning, turning these agents into brilliant strategists. And third, you have to develop advanced reasoning so they can actually think through problems in a logical way.
So if that's the grand vision, how do researchers actually tackle it day to day? What does the science look like on the ground at the keyboard?
It's kind of surprising, but a lot of that incredibly complex research boils down to making these three fundamental steps better. This is the core loop, the very heartbeat of any autonomous agent. How well can it perceive its surroundings? How intelligently can it create a plan? And how effectively can it execute that plan? Every single breakthrough you hear about is really just about making this loop faster, smarter, and more reliable.
And this is where the research gets really specific. Let's take that first one, RLHF. That's reinforcement learning with human feedback. It's basically training an AI by having humans grade its performance, kind of like a teacher helping a student learn how to plan things out better. Other research is all about teaching AIs to use tools, like a calculator or a web browser, to get better at acting in the world.
So, behind all this abstract research and all this code, there are people. Who are these explorers pushing the boundaries of what's possible? What does it take to become someone who actually builds thinking machines for a living? While this is a field for deep specialists for sure, we are talking about people with advanced degrees, PhDs, masters, in AI, computer science, or even cognitive science. And all of that is backed by a super strong foundation in math and statistics. That kind of passion is what leads them to careers as research scientists, academics, or into the incredibly important field of AI safety.
Okay, so what's in the toolkit for these builders? Every explorer needs their equipment, right? And in this case, that equipment is all software. So let's take a look at the essential platforms they use to bring all these ideas to life.
Everything, and I mean everything, is built on just a few key foundations. Python is basically the official language of AI, just because it's so flexible and easy to get started with. Then you have these incredibly powerful libraries like PyTorch and TensorFlow. These are the heavy-duty engines that do all the complex math you need to build and train these massive neural networks.
Now, on top of that foundation, researchers use a whole layer of specialized tools. Think of Hugging Face as a massive online library of pre-built AI components. Then you've got environments like OpenAI Gym, which are basically virtual playgrounds, almost like video game worlds, where agents can practice tasks millions and millions of times. And to keep track of it all, platforms like Weights and Biases act as a digital lab notebook, meticulously tracking every single experiment. And finally, you have the actual blueprints themselves. These are the specific recipes or designs for building really capable agents. For example, a framework like React is designed to make an AI think out loud, to reason through a problem step by step before it acts. These kinds of designs really represent the absolute cutting edge of the field.
So, we've seen the mission, the research, the people, and the tools. It's an absolutely incredible journey toward creating these truly autonomous systems. But it leaves us with one final and really crucial question. As these agents become more and more powerful, more and more independent, maybe the most important research of all is figuring out how we make absolutely certain that what they want is what we want. Something to think about.